class. Today I'm coming to you in this video with 3.5, looking at implicit differentiation. My last video for 3.4 was a little too long. I'm going to try to keep this one a bit more simple as best I can. So let's get into it. So implicit and explicit functions. Let's talk about it. Most functions are expressed in explicit form. For example, let me share my screen. We've at this point pretty much just been talking about explicit functions. So let me show you. All right, so here's 3.5, implicit differentiation. So most functions have been expressed in explicit form. For example, you've got the function y equals 3x squared minus 5. And the variable y is explicitly written as a function of x, okay, which we can clearly see. Some functions, however, are only implied by an equation. For example, the function y equals 1 over x is defined implicitly by the equation x times y equals 1. So to find the derivative of y with respect to x for this particular equation, this is the implicit form, okay, where it's no longer solved for y. So take note, in this form, the function y is explicitly solved or written as a function of x, but not always. What if we took this function and basically rewrote it with the x over here with the y? There, in this form, we call this the implicit form. So if we have a function or an equation written in implicit form, but we want to still find the derivative of it with respect to x, then when you're able to, you want to write y explicitly as a function of x. So in other words, if you're given an implicit equation and you can solve it for y, that's what you would want to do. Because from there, then all you would have to do is apply your derivative formulas and rules that we've looked at this point. However, if it cannot be written explicitly, in other words, if it cannot be solved for y, then you have to figure out a different way to get the derivative, okay? So this implicit equation, this equation written in its implicit form, can be solved or can be rewritten in its explicit form, okay? And then the derivative would just simply be taken, the derivative of y would be taken with respect to x, and there you would have it. So this strategy, the strategies and techniques that we've been looking at this point, would all work for all functions that are explicit in format, okay? However, it won't work if you're unable to solve for y, if you have an equation that you cannot solve for y, okay? In other words, you can't write that equation in its explicit form where y is a function of x, if you cannot solve it for y. Here's an example where you cannot explicitly solve this for y because you've got a y cubed here and you got a y there. So in other words, even if you were to solve for this particular y, this term, your function that would be over here on the left side would still be involving y as well. So you would still have y in terms of y, okay? So for this equation, it is difficult to express y as a function of x explicitly. So in other words, so in order for us to find the derivative, we have to use something called implicit differentiation. To understand how to find the derivative of y with respect to x implicitly, you must realize that differentiation is taking place with respect to x. So you still have to keep that in mind. That even though you might see y, you're taking the derivative with respect to x. So what that means is, when you differentiate terms involving x alone, you should differentiate as usual. But when you're differentiating terms that involve y, you have to apply the chain rule. And the reason you have to apply the chain rule is because even though you see y, you are assuming that y is defined implicitly as a differentiable function of x. Okay? So you're always looking for the derivative differentiating with respect to x, even if it's a y term. So let me explain what we're doing here. Well, let me show you what we're doing here. So part A, or this example, all of them, says differentiating with respect to x. So if we're taking the derivative with respect to x, this is perfectly easy to do. The variables agree because you're differentiating with respect to x, and this is an x function. So here we just take the derivative using the power rule. We literally just bring down the exponent and lower it by 1. Okay, remember, bring down the exponent, lower it by 1, so that's where we get the x squared there. So here we use simple power rule. And that is again because the variables agree. You're differentiating with respect to x and the function is in terms of x. Okay, variables agree. Look at B though. You are looking to differentiate or find the derivative with respect to x, but you've got a function of y. Variables disagree. So therefore, we need to use chain rule. So you might be asking, well, how do I take the derivative with respect to x, but the function is y? Well, you're going to take the outer derivative, and then you're going to say times the inside derivative. Okay? So here's how we do that. The outer derivative is taking the derivative of that exponent, bringing it down. So that would be 3 times y to the 3 minus 1 power. So this is the outer derivative. And then we say times the derivative of the inside. Well, the derivative of the inside function is y. So the derivative of y would be dy with respect to x. We don't know what the function is. We're just saying it's y. So the derivative of y with respect to x. This is the inner derivative. And it is the derivative of y with respect to x. Okay? So your answer would be 3y squared dy dx. Okay? Let's take a look at this part C. You got a sum of 2 terms. So we're going to break those apart. We're going to take the derivative of the first term plus the derivative with respect to x of the second term. Now here, the variables agree. So we just basically just apply the basic power rule derivative. Derivative of x is just 1. Here, variables disagree. You apply chain rule. So variables agree, that's the power rule. Variables disagree, chain rule. So right here, derivative of x is just 1. Derivative of 3y. So we're going to take the outer derivative, which will mean we bring down the exponent of 1, okay, and lower the exponent by 1. So 1 minus 1 would just be 0. So that would just be 3. The outer derivative would just be 3. Then we take the inside derivative. Derivative of y itself with respect to x would be dy over dx. And that would be your answer. 1 plus 3 dy over dx. So in other words, if we knew what y was, if we actually had or were able to rewrite y in terms of x, then we would take that derivative of it. Okay? All right. Now here, we have a product. So we're not only going to use the product rule, but we're going to use the chain rule within it when we get ready to take that derivative of y. So we're going to start off with the product rule. Oh, and also, you may have to use the product rule occasionally in 3.4. Just like we had to use the quotient rule in 3.4, we may have to use the product rule, because I don't know if I looked at a problem that involved the product rule. So just keep that in mind. As we progress and learn more and more rules, you still got to keep in mind the old ones, okay? So because you got a product, you're going to begin with the product rule. And then what happens is you may have to apply the chain rule within it, okay? So the product rule just states that I take the first, so I'm going to write first, the product rule, so as you can recall it, that does say rule, I can't write, first times d of second plus second times d of first, okay? So first would be x times the derivative of the second. The first term is x, the second term is y squared. So the derivative of the second, I have to apply the chain rule within it. So I would take that 2 down, okay, that would make that 2y. The y now has the exponent of 1, and then I say times the derivative of the inside, so times the derivative of y, which would be dy over dx. Okay, so that's first times the derivative of the second, plus the second times the derivative of the first. Derivative of x is just 1. Okay? Alright, cleaning that up a bit, we got 2xy dy dx plus y squared. If you wanted to simplify it, only thing I could see us doing is backing out a y, but there's no reason to. Not right now, anyway. Eventually, we might want to solve it for dy over dx, but that's another day. That's another later problem. Not right now. Right now, we're just finding that derivative. Okay? All right. So, guidelines for implicit differentiation. And notice now we got an actual full equation here. So guidelines, it says differentiate both sides of the equation with respect to x, okay? So you will have a full equation now that we'll be looking at. Collect all terms involving dy over dx on the left side of the equation and move all other terms to the right side of the equation. And then we will factor out dy over dx from the left side of the equation so that we can get dy over dx by itself. Because remember, that's your goal. You're looking for the derivative. So you want to be able to say the derivative equals. That is the derivative of the function with respect to x. So we want to be able to say the derivative equals. Okay? Let's take a look at this. So remember, we're going to differentiate both sides of the equation. Here's the left side of the equation. Here's the right. So I'm going to put d dx, because I'm differentiating with respect to x, this entire equation. And notice I just start off with derivative of the function with respect to x, okay? That's just general. Then, when I get ready to actually differentiate with respect to x, if I'm dealing with y, I have to apply the chain rule, okay? If I'm dealing with an x term, I just take the derivative exactly, or directly. Okay. All right, so derivative of the first term. The outer function, 3, comes down, and so that becomes an exponent of 2, and then I say times the derivative of the inside with respect to x, so times the derivative of y, so that would be dy over dx. Move on to the next term. Derivative of y squared, I would bring down to 2, and I would have y, and then I say times the derivative of the inside function, so times the derivative of y, which would be dy over dx. Okay? Moving on here, derivative of 5y, that would be a minus 5. And then, because the y drops off, because it would be bringing down the 1, lowering the exponent by 1, so that would just be y to the 0 power. but then times the derivative of y itself with respect to x, which would be dy over dx. This term, the variables match, so I just take the derivative using the general power rule, 2x. And then on this side, derivative of a constant is 0. Okay? So right now I've got three terms here that involve dy over dx. Remember, my goal is to solve for dy over dx. I'm going to take this term that does not have a dy over dx to the other side. And I take it over by saying plus, so it's now positive. That leaves me with 3y squared dy over dx plus 2y dy over dx minus 5 dy over dx. Now I'm going to factor out a dy over dx, and I'm going to leave in the parentheses what's remaining. I'm factoring out dy over dx from all three terms. So that leaves me with 3y squared plus 2y minus 5 equals 2x. Okay? My last step then is to divide out by this whole expression so that I have dy over dx by itself. And of course, whatever I do to one side of the equation, I must do to the other. So I can't there. Dy over dx equals 2x over 3y squared plus 2y minus 5. That is my answer. So again, it takes practice, but it's actually very doable once you practice it enough. It actually is. Let's take a look at some of the problems in the homework here. Let me see if there's anything else I need to mention from my notes. So maybe just more examples. Maybe just more examples. Yeah, pretty much just more examples. Okay. All right. So let's see if there's more to look at here. 1, 2, and 3 are very similar to that one I just did, but I will show you, let's say, number 2. So we're looking for the derivative. We've got, let me get a piece of paper here. Number 2. We've got, and just remember 3.5. We've got 4x cubed plus 5y cubed equals 68. And we want to take the derivative of the entire equation with respect to x. So we have to take the derivative of each side. Okay? Alright, so derivative of 4x cubed with respect to x, the variables agree, so that's just 12, because you're going to bring down the 3. Okay, so bring down the 3, and then lower it by 1. That's 12x squared. Here, you're going to also bring down the exponent of 3 and lower it, but then you have to take the derivative of the inside, because this is the outer derivative, and you still need to take the derivative with respect to x. So we have to assume that y is a function of x and say times the derivative of y. So this would be plus 15y squared times the derivative of y with respect to x, which would be dy over dx. And then that's equal to a constant, derivative of a constant, which is 0. Okay? So now I only have one term that has dy over dx in it, so the other term that does not, I'm going to take to the other side. So I got 15y squared dy over dx equals a negative 12x squared. And then I want to get dy over dx by itself, so I'm going to divide out by 15y squared on both sides. So over dx equals this, but we simplify because 12 and 15 have at least a 3 in common. Yeah, just 3 actually. 3 goes into 12 4 times, and 3 goes into 15 5 times. So this is a negative 4x squared over 5y squared. Okay? Let's see. Number 2 from the homework. Number 3 is similar to it. Let's look at number, let's see here, what I want to do. Yeah, they get very involved. Yeah, they get very involved. Let's say we look at number 4. 1, 2, and 3 are pretty standard, pretty straightforward. But we get a little bit more involved, I must be honest with you. You got to think about it a little bit, like dealing with the derivative of ln y, or whatever. Okay. Alright, so let's look at number 4. And like I said, I'm not going to necessarily keep this video as long. If you have trouble with some of the problems, that can be the first thing we talk about in class. We'll look at a few more problems and then we'll go on to the next sections. But you have to practice them. So that's where you're going to learn. So I need to give you a chance to actually practice them first. So x to the 4th times y to the 4th minus y equals x. So we're taking the derivative with respect to x of this entire equation, so both sides. Okay, so this is what we have right now. Now, this is a product. So right here, I'm going to have to apply the product rule. And then within the product rule, I'm probably going to have the chain rule. So just keep that in mind. You know, when you're taking the derivative with respect to x, but you've got y, that in itself means you're applying the chain rule, but then this is a product, okay? So remember the product rule first, times the derivative of the second. So we've got first, which is x to the 4th, times the derivative of the second. So derivative of y to the 4th will be 4y to the 3rd, times the derivative of the inside, so dy over dx. Okay? Then we say plus second times the derivative of the first. So that would be 4x cubed. Okay? That's what we have right now. And we're going to clean all that up in a little bit. Derivative of y, well, the outer derivative, you would lower the exponent by 1, bring that old exponent down, so you got a 1 there. And then y to the 0 is just 0, so then you got dy over dx, the inside derivative of the inside function. So it's understood to have an exponent of 1, so the outer derivative, you lower the exponent down, reduce the exponent by 1. So that's how you end up with y to the 0, and it's just 1. Then times the derivative of y with respect to x, which is dy over dx. And that is equal to derivative of this x with respect to x is just 1. Okay? So I'm going to clean this up. I've got x to the 4th. Let's bring this 4, this constant 4 to the front. So I've got 4x to the 4th y cubed dy over dx plus, bring that 4 to the front as well, 4x cubed y to the 4th, and then I've got minus dy over dx, and I got equals 1. So I got 2 times the dy over dx, they're going to stay on this side. This term I'm going to take to the other side, I'm going to say minus. X is there. So I got 4x to the 4th, y to the 3rd, minus dy, I'm sorry, this is supposed to have dy over dx with it, and then minus this dy over dx, and that is equal to 1 minus 4x cubed y to the 4th. Okay. All right. Now I'm going to factor out, I didn't mean to draw that yet. Now I'm going to factor out, let me see if I have some white out somewhere. That way it doesn't look like I'm jumping too far ahead. Because I really should not have had this bar here yet. Kind of already got it there. So let me just kind of cross it out there. Alright, now I'm going to factor out a dy over dx in both of these terms. That leaves me with 4x to the 4th y cubed minus 1. And I still got on this side 1 minus 4x cubed y to the 4th. Last step, I'm going to divide by 4x cubed y to the 3rd minus 1. And 4x, I changed that. That's a 4 right there. That's minus 4. And I'm dividing by this on both sides. 4x to the 4th y cubed minus 1. Cancel this. So dy over dx equals 1 minus 4x cubed y to the 4th over 4x to the 4th y cubed minus 1. Whew, quite a bit to do. So we got it. We got it. Okay. Let me see if there's anything else I want to make sure I talk about. Let's look at number 6. So that's the answer to 4. Let's look at number 6. It might be the last one, and like I said, if you have more questions, I'll answer them first thing in class. But this just takes practice. I can't stress that enough. It's going to take some practice. But this is number 6. Let's get it down. And it is, this is from my homework, number 6, x e to the y minus 11x plus 9y equals 0. And we are taking the derivative with respect to x of this whole equation. So I'm taking the derivative of each side, okay, the whole thing. So derivative of the first term, this is x e to the y. So this is a product. So I have to apply the product rule. So I have to say first times the derivative of the second. The derivative of the second, the outer derivative, e to the y, is just itself, e to the y. Then times the derivative of the inside, derivative of y itself, with respect to x, is dy over dx. Okay? Then I say, so that's first times the derivative of the second. Then I say plus the second times the derivative of the first, which is just 1. So right here, I needed to apply the product rule. That's what I did for that first term. First times the derivative of the second, then the outer derivative is its own derivative, and then times the derivative of the inside with respect to x. So derivative of y with respect to x is dy over dx. Plus the second times the derivative of the first. Then I take the derivative of this next term, 11x. The variables agree, so that's just a minus 11. Then I move on to the derivative of the third term, derivative of 9y. Well, that's just the outer derivative is going to be 9. And then the derivative of y itself with respect to x is dy over dx. Okay? And then that is still equal to 0 because the derivative of 0 is 0. Clean all this up. It looks kind of yucky at the moment, so we're going to clean it up. Anything that it does not have a dy in it is going to go to the other side, but let's kind of clean it up a little bit. So we got x e to the y dy over dx plus e to the y minus 11 plus 9 dy over dx. And that equals 0. So the two terms that do not have dy over dx are ey and this 11, so they're both going to the other side. So this would be a minus ey, minus ey, because it's a positive right now. And this will be a plus 11, plus 11. So it cancels there. So I've got x e to the y dy over dx plus 9 dy over dx. And then on this side, I'm going to write the 11 first, since it's positive. So I've got 11 minus e to the y. Pull out your dy over dx. Okay? When you factor out, I don't know why I got it equal. When you factor out dy over dx, that leaves you with x e to the y plus 9. And you still got 11. Can't keep messing up. And you still got 11 minus e to the y. Last step, get dy over dx by itself, and then divide out by x e to the y plus 9. So that cancels. Dy over dx equals 11 minus e to the y over x e to the y plus 9. Okay. So practice, practice, practice. I can't stress that enough. That's what you're going to have to do. Just practice. Okay. I will stop here for this video, and I will see y'all in person after spring break. Hopefully, please, you can get some work done. I am going to set due dates in for the assignments for this next module. I have not done that yet because I was trying to gauge how long it was taking us to get through it, but I think I can kind of see now a good due date. I will see y'all after spring break. Have a wonderful break. Please do some calculus though. Have a good day.